Question number 66 I have. A compound X having molecular formula C5H8 on reductive ozonolysis gives 2-oxopropanol and methanol. The correct IUPAC name of X is. If we talk about X, we need to just check what is that, on the basis of which we will identify whether these products are formed after their reductive ozonolysis or not, and then we'll find out the correct answer. So simply, if we talk about X, first option is given here. This is 2-methyl 1,3-butadiene. Just checking it first. 2-methyl buta 1,3-diene. The structure would be 2-methyl 1,3 CH2. This is H here and CH2 here. This is the diene. Ozone is added to it to form its ozonoid. So I'm just going to form here the ozonoid of this compound. This way, ozone would be joined here. Similarly, on this carbon also, this way, CH2. Now what will happen? Reductive ozonolysis, when you add zinc to it, here is zinc and H2O. Here is the splitting of this ozonide in this way, this way, this way. So what's the compound that's formed here? It would be C double bond O, CH3, and here C double bond OH. What is this? This compound is, clearly you can see here, this is 2-oxo. Just have a look on this. This is 2-oxopropanol. 2-oxopropanol is also given here in the question. So I'll just underline this 2-oxopropanol. And other part that's formed here, if you look at the structure, this is CH2O. That is HCHO or formaldehyde simply. That's also called methanol. So 2 molecules of HCHO are also formed here. So this methanol is also formed. It means this first option consists of the compound that is compound X. That's why I'll choose this option 1 as the correct option. After this, question number 67. On reaction with benzene, which halide is least reactive for Friedel-Crafts reaction? Friedel-Crafts reaction is the reaction of benzene with some halide. That halide can be alkyl halide or aryl halide in the presence of anhydrous AlCl3. Let's check the given options to identify the least reactive halide. Here is isopropyl chloride, that is simply 2-chloropropane. Then vinyl chloride is there. Vinyl chloride is this type of compound. And after that, there is benzyl chloride. I'm just drawing here the benzyl chloride also. This is CH2Cl in this way, and methyl chloride, very simple one, CH3Cl. You should always remember that if we talk about this compound, this is vinyl chloride. In this case, there is the partial double bond character between carbon-chlorine bond. How? Because this lone pair when comes here, there's a shifting of electron to form another resonating structure. That's the structure of carbon ion. In this way, you can clearly see. And due to the presence of this carbon-chlorine double bond, this is least reactive for the Friedel-Crafts reaction because this bond cannot easily be broken. And that's why vinyl chloride is that halide which is least reactive for Friedel-Crafts reaction on benzene. So this is the correct answer for this question. After this, let's take now question number 68. The maximum number of isomers obtained on monochlorination of 2,3-dimethylbutane is. What is this 2,3-dimethylbutane? First is the structure of butane, and here is 2,3-dimethylbutane. Now what you're going to do? You're just going to do the process of monochlorination. It means we're just going to add chlorine in the presence of sunlight. Now, during this process, how many isomers are formed? If you look at this structure, there are 2 types of hydrogen atom. One is present here in the form of CH3. This one. The similar is present here also at the CH3. This is also CH3, this is also CH3. It means all these hydrogen atoms are of same type because these are the part of methyl group CH3. But if we talk about this one, this hydrogen is of second type because it is CH2, and at which you can add chlorine. Similarly, this is also the similar of that. This carbon, this hydrogen is also similar to the previous one. These two are 2. It means only 2 isomers can be formed. These are the structural isomers. So in this case, the products those you can obtain are this way you have. And suppose this chlorine is attached here. One compound that you will obtain monochloro derivative further. Second can be this way. 4. This is 2,3-dimethyl butane, and chlorine can be attached here. Chlorine. Now, if you look at these two, these are the two structural isomers. But if I talk about this structure, in this structure, if you look at this carbon, this is chiral carbon. How chiral? Because this carbon is directly attached with CH2Cl group at this side, CH3 group at this side. Similarly, if I talk about this, there is this group that's present, and here is hydrogen. This is the chiral carbon, and if it is chiral carbon, it will form 2 optical isomers also. It means one structural isomer is formed, and of this structure there are 2 optical isomers. So total number of isomers those are possible for this particular compound is 3, and that's why I'll choose option 1 as the correct option. After this, there's next question. Question number 69. The major product A in the following reaction sequence is. We have this reaction sequence. We need to just find out the major product A. First is CH3C triple bond CH. This is alkyne, and on this alkyne you are adding NaNH2. Sodium iodide is added here, and in this case there is the formation of product X, that is CH3C triple bond Na. This type of bond is formed by this alkyne. It is showing its acidic nature further. In this case, you are adding another compound, that is alkyl halide CH3CH2Cl. Ethyl chloride we are adding here, and after the reaction there is the formation of CH3C triple bond CH2CH3. This would be the product that you are just going to obtain. What would be the name of this compound? You will identify that this is the compound that is pent-2-ine. Why? Because 5 carbon atoms are there, and at the second carbon there is a triple bond. This is pent-2-ine. And on that basis, I'll choose option 4 as the correct option. After this, question number 70 we have. Question number 70. On reaction with chlorine, benzene forms compound X in the presence of sunlight and forms compound Y in the presence of FeCl3. Identify X and Y. It means reagent is same, substrate is same, but the reaction conditions are different. The first condition is the presence of sunlight, and the second condition is presence of the catalyst, that is FeCl3. So what happened in this reaction? In first case, if you have benzene ring in this way, you are adding chlorine to it, and there is the presence of sunlight. In that case, this gets changed into cyclohexane, in which 6 chlorine atoms are attached in this way. This is the compound that is benzene hexachloride, and this is also known as gamexene or BHC. Further, if I talk about the second case, when you are adding chlorine in a similar manner, but in this case there is FeCl3 that's present. In its presence, this is forming monochloro derivative. It means it will form chlorobenzene. So if this is chlorobenzene, Y is chlorobenzene, X is BHC, then where this is given? This is given here in option 3. X is benzene hexachloride and Y is chlorobenzene. So the answer that's correct for this question is option 3. Let's take question number 71.